Our focus today will be on systems of linear equations. The method of focus is variation of parameters in systems of linear equation. You are given a system in the form of a matrix whereby the A is the matrix -3, 1, 2, -4, and the function f of t is equals to 3t e to the power minus t. Step 1. We determine the solution to the associated homogeneous system. A homogeneous system is whereby your f of t is equals to 0. Therefore, your x prime will be defined by the system -3, 1, 2, -4 multiplied by x. So this is the associated homogeneous system. When finding a solution to a homogeneous system, the first step you have to determine the eigenvalues and the associated eigenvectors. Step 2. We determine the eigenvalues and corresponding eigenvectors. Therefore, we are going to determine the determinant for the characteristic equation so that we can be able to find the eigenvalues. Then the determinant of the characteristic equation, that will be A minus lambda I, is going to be equals to -3 minus lambda 1, 2, -4 minus lambda. Then this will be equals to -3 minus lambda multiplied by -4 minus lambda minus 2 times 1, which is 2. This gives us lambda squared plus 7 lambda plus 10. This will be lambda 5 and 2 plus and a plus. Therefore, our eigenvalues will be -2 and -5. So determine the corresponding eigenvectors to lambda 1. So the basis for eigenspace lambda 1 is equals to -2. That will be, we take the lambda -2 and we substitute it on the characteristic equation. Where there is lambda, we substitute -2. So we are going to have -3 minus into -2 1, and then 2, and then minus 4 minus into minus 2. Minus 3 plus 2, which is minus 1, 1, 2, minus 4 plus 2, that will be minus 2. Remember that for the eigenvalues lambda 1 and lambda 2, the determinant of the characteristic equation is equals to 0. Therefore, this implies that our matrix is minus 1, 1, 2, minus 2. It equals to 0. The augmented matrix for this system will be minus 1, 1, 2, minus 2, 0, and 0. Then we have to put this into a reduced row echelon form and then interpret the result in order for us to find the associated eigenvectors. By row reduction, we can multiply row 1 by 2 and add it to row 2 to get the new row 2. Minus 1 times 2 plus 2, that will be minus 1, 1, and then 2 plus 2, 0, 1 times 2 minus 2, 0, 0 and 0. Therefore, minus x1 plus x2 will be equals to 0. Then x1 is going to be equals to x2. x2 is equals to a free variable. We can call it k, which then implies that x1 is also going to be equals to k. Therefore, x will be equals to x1, x2 equals to k and k, and this will be k into 1 and 1. Therefore, our eigenvector associated with the eigenvalue minus 2 will be 1 and 1. Now we are going to find the basis for eigenvalue. Lambda 2 is equals to minus 5. Applying the similar procedure, x1, x2 will be then be equals to minus 1 over 2t and t. This will be equals to t minus 1 over 2, 1. The eigenvector associated with the eigenvalue minus 5 will be minus 1 over 2 and 1. We can express this eigenvector in a more simpler form by multiplying it by a non-zero scalar to get rid of the fractions. v2 prime is equals to 2 multiplied by minus 1 over 2, 1, which is then going to be minus 1 over 2. or you may multiply by a non-zero scalar minus 2 minus 1 over 2, 1, which is then equals to positive 1 and minus 2. So either of the eigenvectors, whether you use this one or this one, you must still get the same solution for the problem. We express this eigenvector as k1 and express this eigenvector as k2. Therefore, the eigenvectors will be k1 is equals to 1 and 1, and k2 minus 1 and 2. By theorem of general solution for homogeneous systems, when you have n distinct real eigenvalues of the coefficient matrix of the homogeneous system and the corresponding eigenvectors, the general solution to that system is given by x is equals to c1 eigenvector k1 e to the power lambda 1 t plus c2 k2 e to the power lambda 2 t plus all the way to cn kn e lambda n t. The general solution to the homogeneous system for this problem will be x is equals to c1 eigenvector k1, which is 1 and 1, e to the power, this eigenvector correspond to the eigenvalue, minus 2t plus c2 eigenvector minus 1 and 2, which correspond to the eigenvalue minus 5 and t. We now recall that finding the general solution of the associated homogeneous system is actually determining the complementary solution of the given non-homogeneous system, which is expressed in this form. The complementary solution is equals to c1 x1 plus c2 x2 plus all the way to plus cn xn. Therefore, from this understanding, your x1 is going to be equals to 1 1 e to the power minus 2t, and the x2 will be equals to minus 1 2 e to the power minus 5t. x1 will be e to the power minus 2t e to the power minus 2t, and x2 will be minus e to the power minus 5t to e to the power minus 5t. The entries in x1 will form the first column of the fundamental matrix, and the entries in x2 will form the second column of the fundamental matrix. The fundamental matrix, which is expressed using the function, which is then equals to e to the power minus 2t e to the power minus 2t minus e to the power minus 5t to e to the power minus 5t. By method of variation of parameters, the general solution to the system is equals to the sum of the complementary solution with the particular solution. We determined the complementary solution and the particular solution using the variation of parameters method in systems of linear equation is given by the fundamental matrices multiplied by the integration of the inverse of the fundamental matrices by the function f of t dt. Thus, we have to proceed and determine the inverse of the fundamental matrices. When we have a matrices A, B, C, D, the inverse is going to be 1 over the determinant of this matrix multiplied by, we swap D with A, and then we multiply B and C with A negative. We are going to apply the similar procedure to find the inverse of the fundamental matrix. Thus, we firstly need to determine the determinant of the fundamental matrix, which is then going to be equals to e to the power minus 2t multiplied by 2e to the power minus 5t minus e to the power minus 2t multiplied by minus e to the power minus 5t. This is equals to 2e to the power minus 7t plus e to the power minus 7t. This is then equals to 3e minus 7t. Then the inverse of the fundamental matrix is equals to 1 over 3e to the power minus 7t multiplied by 2e to the power minus 5t e to the power minus 5t minus e to the power minus 2t e to the power minus 2t will be equals to 2 over 3 e to the power 2t 1 over 3 e to the power 2t minus 1 over 3 e to the power 5t 1 over 3 e to the power 5t. It follows that the matrix multiplication of the inverse of the fundamental matrix with f of t is equals to 2 over 3 e to the power 2t minus 1 over 3 e to the power 5t 1 over 3 e to the power 2t 1 over 3 e to the power 5t multiplied by f of t, which is 3t e to the power minus t. Then we are going to have 2t e to the power 2t plus 1 over 3 e to the power t minus t e to the power 5t plus 1 over 3 e to the power 4t. Then the integration of this matrix multiplication is going to be equals to the integration of 2t e to the power 2t plus 1 over 3 e to the power t minus t e to the power 5t plus 1 over 3 e to the power 4t. dt. Then we are going to integrate. Then we integrate the first row for 2t e to the power 2t. Make use of integration by parts. U is equals to 2t, dv is equals to e to the power 2t dt. The derivative of u in terms of t is then equals to 2 dt, and then v will be equals to the integration of e to the power 2t dt. Then v is equals to e to the power 2t over 2. Then the integration of 2t e to the power 2t dt is equals to u multiplied by v, which is e to the power 2t over 2 minus the integration of v, e to the power 2t over t multiplied by du, which is 2 dt. And this will be equals to te to the power 2t minus the integration of e to the power 2t dt. This will be equals to te to the power 2t minus e to the power 2t over 2. The integration of 2t e to the power 2t plus 1 over 3 e to the power t dt is going to be equals to te to the power 2t minus e to the power 2t over 2 plus 1 over 3 e to the power t. Integrate. Similarly, we are going to integrate the second row for minus e to the power 5t. Utilize integration by parts. U will be equals to minus t. dv will be equals to e to the power 5t dt. The derivative of u in terms of t is minus 1 dt. v is equals to the integration of e to the power 5t, which is e to the power 5t over 5. Therefore, the integral of minus t e to the power 5t dt is going to be equals to u, which is minus t e to the power 5t over 5 minus the integration of e to the power 5t over 5 multiplied by minus 1 dt equals to minus 1 over 5 t e to the power 5t plus 1 over 5 by the integration of e to the power 5t dt. Then we get minus 1 over 5 t e to the power 5t plus 1 over 5 times 5, 25e to the power 5t. Then it follows that the integration of minus t e to the power 5t plus 1 over 3 e to the power 4t dt, it's equals to minus 1 over 5t e to the power 5t plus 1 over 25e to the power 5t plus 1 over the integration of 1 over 3 e to the power 4t is going to be 1 over 3 times 4, which is 12, then e to the power 4t. Therefore, the integration of 2t e to the power 2t plus 1 over 3 e to the power t minus t e to the power 5t plus 1 over 3 e to the power 4t dt, it's going to be equals to, we determine the integration of the first row and we got 2 and we got te to the power 2t minus e to the power 2t over 2 plus 1 over 3 e to the power t. And then for the second row, we got minus 1 over 5 t e to the power 5t minus 1 over 25 e to the power 5t plus 1 over 12 e to the power 4t. Finally, the particular solution is equals to the fundamental matrix multiplied by the integration of the inverse of the fundamental matrix multiplied by f of t dt. This is equals to the fundamental matrix e to the power minus 2t e to the power minus 2t minus e to the power minus 5t 2e to the power minus 5t multiplied by te to the power 2t minus 1 over 2 e to the power 2t plus 1 over 3 e to the power t minus 1 over 5 te to the power 5t minus 1 over 25 e to the power 3t plus 1 over 12 e to the power 4t. E to the power minus 2t, we multiply it by this first row. We get t minus 1 over 2 plus 1 over 3 e to the power minus 2t. And then when we take this and then we multiply by the second row, we get plus 1 over 5 t plus 1 over 25 minus 1 over 12 e to the power minus t. When we take this and we multiply with the first row, we get t minus 1 over 2 plus 1 over 3 e to the power minus t When we take this to multiply with the second row, we get 2/5 t minus 2/25 plus 2/12 e to the power minus t. Adding up the like terms, we are going to get 6/5t plus 1/4 e to the power minus t minus 23/50. Three over 5t plus 1/2 to the power minus t minus 29/50. Expressing this in a parametric vector form, we are going to have 6/5, 3/5 t plus 1/4, 1/2 e to the power minus t minus 23/50, 29/50. Hence, the general solution will be the sum of the complementary solution with the particular solution. The complementary solution, we found it to be C1 11 e to the power minus 2t plus C2 minus 12 e to the power minus 5t plus now the particular solution 6/5, 3/5 t plus 1/4, 1/2 e to the power minus t minus 23/50, 29/50. This will be the general solution to the given non-homogeneous linear system.